Starting, and we are live.
Hello, everybody, and welcome to this very special Java user group event, hosted by myself, Jeff Gonzalez, and featuring my good friend Steve Mann. Now, this presentation is on design principles. What are they? Why are they important? And some basic design principles to help you get started on with the concept. I have been a hobbyist programmer 15 years or so. Just started getting into it professionally a few years back, and have seen several use cases where design principles have saved the day. If you're just starting out with programming, you might not see the merit in it, especially if you're only working on small projects. But once projects scale, they start getting unwieldy, and the only thing that saves us, allows us to maintain these projects, are solid design principles. Now, Steve, what's the first principle we're going to talk about here?
Well, I guess you'll start with solid principles. They're the most basic ones.
Right. The solid design principles seem to be the principles where, everything seems to stem from it. It's not, they're not a pattern per se, but they are a principle that will find use in a lot of different instances.
They're basically the basic rules, I'd say.
Yeah,
right.
They're like the building
basic
blocks.
rules to build. Yeah, the building blocks. So they're the basic rules which everyone needs to follow for good design.
The solid principles are broken up into the 5 separate principles. You have the single responsibility principle, the open-closed principle, the Liskov substitution principle, interface segregation principle, and the dependency inversion principle. Now, a lot of these I will be first to admit I'm not too familiar with, but the one that is most important and is, first on this list is the single responsibility principle. If you make a class, say a class for loading a configuration file, that class should only be responsible for that one particular aspect of the program, loading the configuration. It shouldn't do a bunch of other stuff. It shouldn't have a bunch of other unnecessary methods. The only thing that class should do is handle the configuration. It starts getting, if you have one class that does a million different things, it starts getting unwieldy when you're maintaining it. So if you're using the single responsibility principle, that if there's a bug in the way your configuration is loaded and managed, you need to go to that class to fix it. If you're not using the single responsibility principle, it could be anywhere. It could be any method in any class, and you have to hunt it down. It's a lot of debugging. It's a lot of headache. Especially when you get, a couple hundred classes in there doing millions of different things. It gets unwieldy. The single responsibility principle has got to be one of the most important and most widely used principles in the set of solid principles.
Yeah,
now,
I agree to that.
The next would be the open-closed principle. According to this nice Wikipedia article I have open, open-closed principle states that software entities, classes, modules, functions, etc., should be open for extension but closed for modification. A lot of this relies on inheritance. So I'll assume most of you guys are familiar with object-oriented principles. When you create a base class, you shouldn't have to modify that base class itself to get behavior to be changed. You should be able to extend the base class via inheritance. Shouldn't have to worry too much about what that base class is doing. That's about all I can say on that.
So we'll be using this principle ahead during the webinar as well.
The third would be the Liskov substitution principle, and this is it's a very complex explanation to say just use interfaces everywhere.
Yeah.
So you should be able to take my favorite example of this has got to be database abstraction layers, right? So say you have your core business logic that relies on information from a database. Instead of directly making a class that handles all your database operations, make an interface that provides a set of methods that anything inheriting from or anything that implements that interface should implement those methods, which will allow you to say you need to change your data type or your data source. So say you're using a MySQL database and you need to use a CSV file. instead of having to completely overhaul your application, it's a matter of writing another class that implements that interface and passing that instead. It's the Liskov substitution principle effectively states that you should be able to replace any instance of a base object with anything that inherits it without modifying the behavior of the application. And that is, well, like I said, is most useful with database. It finds some use in your networking side as well, and I'm sure there are a million other uses that I haven't seen before. But those are the two that I find almost on a daily basis. Steve, you have anything to add here?
Yep, I was just replying to one of the guys who's joined the live stream. Dipanshu's here. Dipanshu Dwani. Dipanshu Dwani, one of my friends, just joined the live stream.
Hello.
I haven't met him like in 4, 5, 6, in 6 or 7 years, but we've been friends, right?
Yeah.
So, yeah, you can continue.
All right. This brings us to I of solid, which is the interface segregation principle. So if you have interfaces, shouldn't be forced to rely on methods that they don't actually use. So you shouldn't have an interface that you shouldn't have something that implements an interface that doesn't actually use parts of that interface. It's it seems intuitive. It seems like it shouldn't have to be stated, but you'd be surprised at some of the things that actually make it into production.
Yeah.
The next thing you know, you're having not implemented exceptions thrown up left and right, and people get all sorts of upset. Which brings us to our last principle, the dependency inversion principle. This one I actually don't know too well. Steve, can you speak to this?
Dependency inversion is basically making a class not dependent on anything. So instead of like one class depending on other, you just invert the dependency, and instead of saying that you give me this, you say that I'll provide you this. I'll provide you one of the objects, or I'll provide you one of the functionality. And so that's how dependency inversion works.
Okay.
Yes, so dependency inversion, I mean, we'll talk about strategy pattern later during the webinar. And it's basically dependency inversion. It's advanced form of dependency inversion itself.
I'm interested to see it.
Yeah, me too.
All right, and that brings us to the end of the solid principles.
Yeah.
They're something that every developer should learn early and use often. It will make your life so much easier.
Definitely, definitely. And I'd say designing good code is more important than to make it work. Because you not only have to think about yourself, you have to think about the people who have to maintain that code years later.
Right. A program gets read more often than it gets written. If you take the time while you're writing it to make sure it's clean and well designed, it will make your life so much easier later on while you're maintaining it.
And no one will curse you.
Mm-hmm. You don't have to worry about somebody showing up to your house in the middle of the night and yelling at you or beating you or what have you.
Yeah. So writing good code is important, as important as writing correct code. Right.
So at this point, I will go ahead and turn the floor over to you, Steve. What do you have for us?
Well, let's see. We've talked about why design patterns are important, and we'll go on with first design pattern we have. We'll discuss the Singleton pattern. It follows the single responsibility principle very well. And so let me just share my screen. Yeah, here we go. So I hope everyone's able to see the screen. Jeff, you're able to see the screen, right?
Yep, I can see you.
And let's just move on to the chat for a while. Let's see if there's anyone there. Yeah, I guess it's working. And so what singleton pattern is, what singleton pattern does is it gives you just one instance of the object, one instance of the class. So the thing is, there are some cases where you only need one object throughout the application. You don't need different objects to do different things and so on. You need one object, and that one object manages everything. So, like for example, if anyone has studied JDBC, so when we connect to the database using the driver, we don't create a new instance. We ask for a new instance, like get connection using the get connection method. So what it does is it gives the one and only instance of the class, which is used to maintain everything. Similar case for loggers. There should be one logger instance which logs everything throughout the program. So how does singleton work? So let's say we need to get the singleton instance. We firstly make a reference, and what we'll do is we'll make it static singleton, and we'll call it singleton. We'll need a constructor as well, and we don't need constructor right now as of now. So we'll make a method, a public static method to get the instance. Return the singleton and name get instance. And what this does is it returns the singleton object we are about to create. What's the matter here? Our returns damn. So there are three ways basically to create a singleton and use singleton pattern. First is we'll use static initialization. We initialize this new singleton right here and right now. So what this does is we make this singleton instance private, so we cannot access it anywhere. And we will get this singleton instance from the get instance method. So let me just create a new class and see if this works. So I have the singleton client here, and we need to make the main method. In this singleton client, what we need is a singleton instance. Singleton, let's say, test object equal to. If we try, let's try a new singleton. I mean, this works actually, but this shouldn't work. That defies the purpose, the only purpose of our singleton class, that we should not be able to create a new instance on the client side. So to stop this, what we need to do is we need to make the constructor private. And what this does is, now when you create this new singleton, because the constructor is private, you cannot create a new singleton from anywhere outside this class, outside the singleton class. So this will show up an error like the constructor singleton is not visible. So we are forced to use the static method. get instance method. Now this compiles. So what this does is it returns singleton, and what singleton is, it's a private singleton instance, and we created the object there and then itself. But one of the problem with this is this new object will be created there and then as soon as the class loads. I mean, you may or may not need this singleton instance for like a lot of time, but this will load up into the memory as soon as the class loads. And if you have a lot of singleton instances, it'll take up a lot of memory. So the second thing is, the second way to do this is lazy initialization. So what we do is, instead of creating this new singleton here, we will create a new singleton instance in the get instance itself. So if singleton is null, we create a new singleton and return the singleton instance. So this is more like when you call the singleton's get instance method, what it'll do is it'll go to this method, this the method we are calling, and see if singleton is null. So in the first case, if you run this first time, singleton will be null because it is not initialized to anything. So when it is null, it initializes singleton to a new singleton instance and then returns singleton. But if you run this second time, if you use the get instance method second time, it'll just skip through this if method because singleton is not equal to null. It already created a singleton instance. So what we end up having is, we end up having only one singleton instance. So let's see if our analogy is right. What I'm doing here is just printing the object to string. Let's run this one and okay. So yes, we have the same hash. So we know that this is the same object. We are getting the same object, right? So no matter how many times you call or where you call singleton.get instance, you'll end up having one and only object. But then again, this works in most of the cases, but people like Jeff, they are fans of thread. They use threading everywhere. So what if two or more threads call the get instance for the first time at the same time? So if they're calling the get instance method at the same time, all of such threads will see that singleton is null, and that singleton, they'll create a new singleton. So basically, if three threads are calling this at the same time, three new instances will create, which defies the purpose of singleton. So what we are supposed to do for that is we'll use a double check mechanism for this. So how to do that? I'll just write the code first. And if singleton is null, And this is the double check we are doing to make it thread safe. So what this does is it'll check if the singleton is null, and if it is null, it'll go to this synchronized block of code. And synchronize, what synchronized does is it restricts threads from using a block of code simultaneously. So what happens is if two or more threads try to access this same block of code at the same time, one of them will get locked and it'll wait for the other thread to complete its work and then it'll start. So what will happen is, in case we're assuming two threads call this at same time, both of them will check if the singleton is null. Right, singleton is null. Now because of this synchronized code, only one of the threads will be able to go inside this block. So that one thread goes inside the blocks and it again checks if the singleton is null. And in our case, singleton is null and it creates a new singleton instance. And as soon as it gets out of this, the other thread that was waiting, it goes into this block and it checks if singleton is null. Now this time singleton is not null because the other thread created the new instance. So it'll just skip through this and both will return singleton. What we end up having is, we end up having the same object. Even if, I'm not creating threads right now, but we'll end up having the same object. That's the whole purpose of singleton pattern. So where are singleton patterns used? Typically, singleton patterns are used for global configuration. The simplest example would be the log manager. There's a static log manager.get log manager method, and a single global instance is used for logging all over. Another example, like I said, in JDBC would be connection. The driver manager.get connection would get the connection instance. If we go deep into that, it doesn't really follow singleton pattern, but that's how things work. We assume right now, we'll assume that it is a singleton pattern. So singleton pattern, like we said, can be used for logging, database configuration, etc. stuff wherever single instances need. Now, let's go back to the chat. Jeff, you're able to hear me?
Yes, I can hear you.
Yep. So that's all for singleton, I guess. If there are any questions, if you can go to the live stream and see if there are any questions.
I'm not seeing anything in chat. Does anybody have any questions on singleton pattern?
We'll probably wait for a couple of minutes then.
Yep.
Meanwhile, Jeff, tell me, how's life in Iowa?
Oh, lots of cornfields. That's about our main feature here is, we have, if I would go 5 miles in any direction, we're surrounded by cornfields.
Right. A lot of corn.
Mm-hmm. Otherwise, it's very quiet, kind of peaceful. Not too bad overall.
If we talk about here, where I live, if you go even 100 meters from where you are, you'll find at least 5 people.
5 people? That's the population density, man. That's too many people.
Yeah. So no cornfields, it's just people. And in fact, Delhi is one of the more densest cities in the world.
I saw that from some of the images you sent me of how your commute is every day. It seems like there's too many people for the public transportation.
It's not that too many people are using the public transportation. There are people who are using private vehicles too, but the fact is, there are just too many people. Simple as that.
I got an idea. I've got an idea. You've got to replace some of the large segments of population with cornfields. Makes it a lot more peaceful.
You're not talking like Trump. So how do we replace people with corn?
Um, I don't know. I'm not a biologist, but I'm sure there are biologists out there that would be able to tell me.
So maybe black magic. Are you talking about black magic?
Yeah, that could work.
Whoosh,
We could find ourselves some witches and what have you.
like whoosh, and you turn into a cornfield. Simple.
Exactly.
It'll make this world a lot more peaceful. I mean, how about that? If like Osama bin Laden, we use this magic. Like Osama bin Laden, you're the most wanted terrorist. Turn into cornfield.
Now the real question is, would he just be one corn stalk or would he be an entire field?
Uh, that depends, I guess, on the witch, the power of the witch,
Yeah. So we just
and
got
the
to find ourselves a
personality,
really powerful one.
and the personality as well. I mean, you can turn Trump into a cornfield, I guess. He'll be just
No, he
a
would
single
he would just
stand.
be he would just be like the empty plot of land part of the cornfield.
Right. So it depends on the personality as well, I guess. So, enough of that. Do we have questions yet? Any questions?
Nothing popped up, so I'd say we're ready for our next topic.
We have 5 users at least, 5 viewers, right? I mean, that
Yeah.
works, doesn't it? Having 5 users, 5 viewers. I don't know why I'm calling users. And by the way, did I mention you look handsome?
Oh, thank you. You look pretty handsome yourself. Dashing young lad
Yeah,
over there.
I'm the most handsome guy. Really.
Mm-hmm.
Most dive for me here.
You're bringing the charisma and the good looks to the team here.
Yep, definitely. I mean, nothing too offensive, but yeah, I agree to that. Let me just go back to Singleton. So, let's start with strategy pattern, I guess. Right? Should we?
Sure, that's the one I was most excited about.
Haha. Yep, me too. So, coding is slow. Like doing live coding is quite slow. What we'll do is, before I make the project, let's talk about what we're trying to build. Right. So I have a problem statement with me. We require to make an application which simulates Zoom. Zoo, basically, where animals are kept in cage, which is not the right way, basically. But still, coming back here, and hence we need to simulate animals as well as humans, because humans go to see animals in zoo, animals locked up in cages. So this is the problem statement. We need to simulate a zoo. So what we need to do is, let me just create a project. I'll call this phase one. We'll try to make what a newbie programmer would try to do with this. So what a newbie programmer will try to do is he'll create an animal class. He'll create an animal class, and animals basically have behavior. Like they move, they make different sounds. Each animal looks different. So we'll try to simulate this, these behaviors. So to do that, we'll make a few methods. So we don't care right now how this animal moves. All we care is it does move. So we won't provide the implementation for sake of simplicity. And probably all animals make sound. We'll have this one method as well, and making sound. So also Now, these are the common attributes that all animals have. So if we extend this class and make an animal, that animal will move and it'll say it is moving. But for we call it, we say display, to show how the animal looks. Now we cannot have a generic thing for the display. So what we'll do is we'll make an abstract method display. Right. So because we have an abstract method, we'll need to make this class as abstract as well. It works, right? So now to create animals, what I'll do basically, what I'd do is, let's say we create a dog, right? And dog extends animal. Simple as that. Now this is showing up error because we have unimplemented methods. I don't know why this is showing up like this, but we just try again. And yeah, so we had, if we see an animal, we have an abstract method display, and we need to provide the implementation of that abstract method here and here right now. So we have, this is a dog. Simple. Now let's move on and create a few more animals. I don't know if you love snakes or what, but I'll create a snake as well, which also extends animal. And again, what we need to do is we need to provide the implementation to the abstract methods. And this guy looks like a snake, and that's what we'll say. So we have people as well in zoos, probably mostly visitors. I don't hope there are any people in the cages, but we'll create a person, and person is also an animal biologically. So this also extends animal. And again, out, and person says I'm a person. So if we just go ahead and have a look at how this will work. So we make a client, and because all of the animals extend the animal class, so what we can do is, instead of saying person person, we can say animal person. This will have its own limitations, yes, but this is how polymorphism would work. We can say here person, we don't have any problem with that. And we can call person dot move, I don't know why this is, I have absolutely no idea what's wrong here. Yeah, shit. We need to create, silly me, we need to create the main method. I mean, we cannot call, now don't say where ads is not supported. We'll stick to the array. So we can say person dot move, right? Now what? Yeah, let's bring this up here, and yeah, finally it works. So we can call person dot move, we can call person dot display, we can call person dot make sound. So as soon as we run this, it says moving, I'm a person, and it is making sound. But now what we do is, instead of creating the person, we'll also create a dog. Dog is not God. And we'll do the same for dog as well. Dog dot move and dog dot make sound and dog dot display. If we actually try to run this, we'll notice that person is moving. I'm a person, and we are making sound. The person is making sound. Now dog is moving, but we don't know if the dog is moving. It just says moving. It's the default implementation of how animals move. There's no specific implementation right now of how dog moves. Definitely this is a dog and dog is making sound, but what sound? We don't know. So to cover this up, what the programmer would try to do is he'll again override at the rate override public void move. We'll try to override the move method, let's say, and provide the implementation of how dog moves. Right. And now if we go back to the client and try to run this time this says dog is moving. And similarly for all the other animals, we can do the same. We can override the methods, the implementation of animal, and provide our own implementation. Now problem with that is animals, the implementation provided in the animal is being overridden here. And maybe dog, we have a German Shepherd, let's say, we have another breed. So we create two different classes, and they basically both will move the same way because they have four legs and they'll walk in a similar manner. And if we override this, if we override move in both of them, there will be a case where there will be a lot of duplicate code. Now, similarly, if we have different breeds of cats or horses, let's say, they'll all move the same way. Providing the implementation in the class that we're using is not a good idea, because also let's say dogs, uh, it's not biologically possible I guess, but dogs, they all start moving on two legs. So if we need to modify the movement of each dog, let's say we have three different dog implementations and every one of them overrides the move method, we'll have to change their movement in all three of them, right? Which will definitely lead to some errors because you miss out one of the dogs, you don't know where the dog is, where the dog implementation is, and so on. So also, let's say we add some birds. So if we need to add birds, let's say we will need to make a fly method because birds fly. So fly is also one of the behaviors of animal. Now, if we want to create a bird, let's say we create an eagle. And eagle extends animal. And we have a few unimplemented methods here as well. So display is simple. Sysout, this is an eagle. Simple enough. The fly method, it's simple. We can implement how the eagle flies. I don't know why it asked to remove the override annotation. Let's try that. Yeah, this works. But what happens is, now each one of the animal, it has one unimplemented method, right? So we need to override the fly method in each one of them. Now it doesn't make sense if we need to implement the fly method in dog because dogs can fly. So there's a workaround. We'll say can't fly, and similarly for others as well. I mean, snakes can fly, persons can't fly. Save it all, and error is gone. So now what ends up happening is we needed to add a behavior, and to add this behavior we needed to change each and every class of this program, which is definitely not a good idea. So this simply just a lot of hard work. So what if instead of this we use interfaces? Instead of having a superclass animal, we have interfaces which tell which animal gets which behavior. I guess that will be easy. I don't know how many of you agree with me here, but let's just try that out. We have the phase 2, and what we do is we create an interface to provide the behavior, like the fly behavior. We create an interface and public void fly, like this, simple as that. Let me just close all of these. Similarly, what other behavior we had? We had the behavior move, right? And we should call it movable. Let me just call it movable. And also let's just refactor this and rename this to flyable. It's it's much more convenient this way. What other? We have an interface make sound. I mean, there's no able for make sound. There's no able word for make sound, I guess. So we have this make sound which has public void make sound, and we had movable which has public void move. And you people shouldn't be using the default package for all this. There should be a different package for all, but I'm just keeping it simple. Now what we do is, let's say we create this person, and we don't create as animal superclass here. We can create one, but what we're trying to do is this person implements. Persons can fly, so it doesn't implement fly. It implements movable because people can move, and it implements make sound. Now we have to provide implementations of the unimplemented methods. So let's say this out, move, moving, and let's be specific. Person moving, and yes, I speak. This person can speak, this person can move, but this person cannot fly. If we call person dot fly, it doesn't make sense, right? So we move on, and this time we create an eagle. Let's say eagle implements. Eagles can fly, so it implements flyable. Eagles can move, they have legs, move able, and eagles can make sound. I was just googling the other day what sounds does eagle make. Apparently eagle screams. So we'll just do that. Eagle screaming. And eagle can move. We provide the implementation here, but for the sake of simplicity, eagle is moving. We just print out a simple out of println statement. Now, eagles can fly. This is the most important thing. Eagle is flying. So eagles can fly. Now, if we create a client like just we did, so how to use this? To use this, we need a client, and we needed to create an public static void main. What we do is we can have other animals, but let's just try. Let's just try here with person. Person is equal to new person, and eagle equal to new eagle. A person can move. A person can move. Person can make sound. But if we try to call a person dot fly, it doesn't compile. It says the method fly is undefined for the type person because we have not implemented the fly method because we have the person doesn't implement flyable, right? But if we do the same for eagle, eagles can move, eagle can make sound, and or eagle can fly. This was what we are looking for, and it works just fine. It compiles just fine. Let's just try to run this. And the person is moving, and yes, the person speaks. Eagle is moving, eagle is screaming, and eagle is flying. So this works as we intended to do. Now we can make all the other classes. We can create dogs, we can create horses. Horses move, horses can't fly unless it's a Pegasus. You can create a Pegasus and implement the fly interface, flyable interface. So it just makes everything easy. And this was basically what the Liskov substitution principle wants to say, that you have an interface in between everything. But the problem here is the person class is providing all the implementation of a person. Now providing implementation there and then is why we did not use this previous implementation we had, which did not involve interfaces. So there also, like we see this eagle from previous implementation, we were implementing the fly and display method there and then itself, which means there will be a lot of duplicate code. Again, this makes making new animals easier adding new behavior easier, but code duplicacy is still a thing. If we create different persons, like there are 10 or 20 different types of people, but they move the same way. So each and every time move will have an implementation in that class, which is, I mean, a lot of overhead. This surely does solve a big part of our problem, but using inheritance in this way completely destroys the code reuse. I mean, we have to provide implementation again, like for each and every animal we make. So what we will do is, now we're starting talking about the strategy pattern. What strategy pattern does is it takes the parts that vary and encapsulate them so that later you can alter or extend the parts that vary without affecting those that don't. So let's say we have different implementations of animal itself. Mostly in our case, mostly all of the things vary. Move varies, like eagles don't move the same way a person moves. Sounds vary, display definitely varies, and fly method also varies. If we come here, most of our behaviors in this example, they vary. So we'll try not to provide implementation in animal class or any of the subclasses of animal, but will encapsulate the behavior so that later we can alter or extend those parts. So let's move on to strategy pattern. How strategy pattern will work is we'll have a set of algorithms, a family of algorithms, which will tell us how this behavior works. So let's say, I mean, we'll still use interfaces, but we'll see how this is far better than previous implementation. We have an interface move, which will tell the family of these algorithms how to move. Public void move. Now this is the base of the family of the algorithms. This is what binds it all. There can be different ways things move. So for that, we'll say we'll encapsulate the behavior like walking, walk on four legs, we'll say, because animals walk on four legs. And this implements move. Provide the implementation here. Walking on four legs, right? So we are providing implementation in a different class altogether, and we'll be using this to tell what an animal will do. Let's just make a few more behaviors on move only. So let's say uh, humans walk on two legs, right? This is the behavior, and this also implements move. Let's just implement the unimplemented methods. This out. Walking on two legs. That'll be what humans will be doing. And we have a snake. We considered a snake object as well. So let's say snakes crawl. Crawl also implements move, and the unimplemented method is okay. This, hold on, I'll just save it all. Yeah. So these four things, we have an interface, and we have three classes which implements the move interface. Now this is a family of algorithm. This crawl is an algorithm. It provides behavior, and move is what binds this set of behavior, because move is what each and every one of this is doing. Walking on four legs, that tells how this is moving. Walking on two legs, this tells how this thing is moving. This is a family of behavior. You can choose how things move, and we'll see that in a while, but we'll first create the families for sound, for make sound and fly as well. So we have this interface sound which says public void make sound. Now what kinds of different sounds can it make? And by the way, the move implementation, you can move that to different package. The sound implementation, you can move that to a different package for sake of readability and ease. But I'll just go with this. So let's say a person speaks. You create a speak behavior, and it implements sound. And let's just implement it. This out. Speaking. Speaking is well enough. What other sound behaviors you can think of? Scream. Eagles scream. This implements sound. Coding live can be a little boring sometimes, but we also had a snake. Snake hisses. Hisses, right, hisses. Implements sound, and yes, and provide me. Hold on. Unimplemented methods, this out, this in. So I guess that will be enough for sound. We can create now an interface for fly behavior as well. What fly will do is public void fly. It should be small f. Yeah. We provide what types of different fly behaviors we can think of. Either the thing flies, implements fly, and or and fly. This out and fly. So that's basically all of the behavior we needed for this. Let me just save it all. We had an error. No, we don't have an error. Now what we'll do, we have behavior. Now we need to create the animal instances, animal classes. So we'll create an animal, and we will inject this behavior in this animal class. Now, what we'll do is to inject sound behavior, we won't be creating an object of any of the sounds, but we'll use polymorphism and we'll strategy. We call it sound strategy. Similarly, for move, we call it move strategy, and we have a fly strategy as well. What this will do is we'll use polymorphism and we'll point any of the sound strategy, any of the sound implementations to the sound reference we want to create. So how this will work is now animals can make sound public. We'll just provide a few more methods. Make sound. And what we'll say is sound strategy dot make sound. Simple as that. Similarly, public void move. Move and public void fly. Fly strategy dot fly. Simple as that. Now, if we want to create, let's say, a person, create a person class, and person extends animal, we will have all of those members, the class members we have. And now, in the constructor, we can tell what kind of behavior the person will have. So we actually made it private. So we'll have to get the setters working. Let me just see if I can find. Yeah, so we have the setters, right? Now if we want to set the sound strategy, set sound strategy for the person, what will be the sound strategy? A person speaks. The sound strategy will be a new speak object. What's the move strategy? A person move walks on two legs. That's how a person will walk. Set fly strategy. A person can fly. A person cannot fly. So that happens in the constructor, and we can each person looks different. So we can have a public void display method which tells yep, I'm a person. That's how you create what's the matter. We need to save this one. That's so this is how you'll create a person or anything, any animal, and each of the implementation you'll provide You'll just say how that thing behaves, and all of the behavioral implementation, like speaking, is encapsulated and it's far away from the actual implementation of a person. Now, not only you can set how a person makes sound, but you can also change that on runtime. We'll see that in a moment, but just let's just create a dog maybe. We'll create a dog. Dog extends animal, and in the public dog, in the constructor, we'll set the behavior of the dog. Set sound strategy. New. Now that's here's the thing. Here's the thing. Here's the thing. Now let's just keep dog here and let's move on to making the client and see if things work. Public static void main string args. Let's just create an animal person equal to new person and person dot fly. We simply call person dot fly. If we run this, we save everything and it just says can't fly because a person cannot fly. If we say person dot make sound, what ends up happening is it speaks. Now let's just assume we need to add one of the behaviors, like we are making a dog. Dogs bark, right? Dogs cannot speak, dogs don't scream. Yeah, well, they eventually scream, but that's not the scream we're talking about. And dogs don't hiss, dogs bark. So if we need to, this is one of the reasons why we use design patterns, because let's just implement a bark. A dog barks. We know that the dog barks. To do that, we need to create one class. We say it implements sound and implement how this barks. Right. We did not change any of the code, any of the other code. Neither did we change the animal code, neither did we change the sound or any of the other sound implementations. We just made a new implementation part, and now simply we can say set sound strategy and new part. This is as simple as this. Now let's just implement other flag strategies. How does dogs move? They walk on four legs, and we can implement the display method as well. This is a dog. So in the client, if we try to make a dog, create animal of equal to new, not animal. We need to create a new dog and call dog dot fly. It can't fly. If we call dog dot move, obviously it will move on four legs. If we call dog dot make sound. But this is interesting. We did not change any of the existing implementations. We did not change the animal class. We just added a new behavior, which is bark, and said that this dog barks. Simple as that. Now, if we run this, it's barking. The dog barks. So that's basically how strategy pattern works. We provide the implementation. We provide the implementations different to the class. And this again, what we were talking about solid principles. We were talking about the first principle. S stands for single responsibility principle. So this class his. All this class does is provide an implementation of how to hiss. Similarly, scream, speak, can fly. They all have one and single responsibility. Right. Now we have seen that we can add new behavior quite easily. Let me just drink some water. Yeah. So the fact is, we can add more behaviors or strategies without really breaking the existing code. We don't need to modify the existing behaviors to add a new behavior. So again, we saw we added a bark. Now let's say somehow this person flies, right? Somehow magically this person can fly on jetpack maybe. So we add a new behavior, fly on jetpack. That I guess makes some sense. It's not completely illogical. Implements fly and this is flying on jetpack. Now, even on the runtime, what we can do is the person here cannot fly, but we change person dot set fly strategy to new fly on jetpack. And now if we call the fly method, what we observe is it can fly and it is speaking. Now, as soon as we change the fly strategy, this person can fly on jetpack. This person somehow gets a jetpack from somewhere. Maybe one of his friend gifted him on his birthday. And now this person can fly. It's the same object. We just change the behavior dynamically. And so not only we can add new behavior easily, but we can change the existing behavior dynamically on the runtime without breaking the code. So that's how things happen. So let's just give a formal definition of what strategy pattern is. Strategy pattern defines a family of algorithms, encapsulates each one and makes them interchangeable. So strategy lets the algorithm vary independently from clients that use it. Let's just go through what we just said. Strategy pattern defines a family of algorithms. Yes, we defined a family of algorithms. We defined move and how it moves. It walks on four legs, it walks on two legs, or it crawls. So we defined a family of algorithms. Similarly for sound and similarly for fly. We encapsulated each one of them. Each one of them is a different class which provides the implementation. And we make them interchangeable. Now, if in animal, here, we said that this animal, we, instead of using the generic sound, we provided one of the implementations like hiss. Now, this animal will only hiss. We cannot interchange with this with anything. I mean, if we want to set the strategy as bark, it cannot set the sound strategy as bark because it is expecting an hiss object. But we're using polymorphism. It's expecting a sound object. Hiss is a sound, bark is a sound. So we can use all of them interchangeably. Let's go back to the client. Strategy lets the algorithm vary independently from clients that use it. The strategies can vary. A dog, which strategy the dog uses, I mean, it's none of the business of client. Although it can change the behavior. I mean, why not dogs have jetpack? Let's give this dog a new jetpack. And then if you call fly, this will fly on jetpack. So the algorithms can vary. Now to make you understand this, I have this UML diagram. This is what we did basically. We have move interface, we have different move implementations. We have sound interface, we have different sound implementations. We have
The
fly
diagram
interface.
isn't coming through.
Hold on. Hold on. Uh, Let me just go back here and hold on. I have that on different workspace. Let's do this workspace and sharing the screen. Yep, you can see the diagram, right?
Yep, there it is.
So let's just zoom this in. We have move interface and we have different move implementations. Now this is encapsulated move behavior. We have sound interface, we have different sound implementations. We can add more implementations on our convenience. The fly method, we have the fly interface, can fly, can't fly, and can fly on jetpack. Those are encapsulated fly behavior. We have an animal where all these behaviors get changed. We can change this behavior for an animal and provide the implementation is not provided neither as animal or any of the subclasses. The implementation is provided here for the, like say sound. The implementation is provided at bark. That makes the implementation and usage part different. So for a person, all we need to do is maybe implement display method, or we can also encapsulate the display behavior as well. Or we can set fly strategy on runtime, like I said. So this is basically what strategy pattern does. Right, it seems complex, but it's not that complex. We probably, I mean, if we go back to Eclipse, if we go back to Eclipse, you can see that, right? So we have a lot of classes and different files. I mean, we can organize them in different packages. Yes, we have a lot of files, but it makes this code a lot more maintainable, a lot more readable. We know each, I mean, the other person working on this project will know every animal has a fly method. It's a different matter if it can fly or it cannot fly. So he knows there's a fly method. He creates a new animal, let's say an eagle, eagle dot fly. He just calls eagle dot fly, eagle dot move, and eagle dot make sound because he knows those methods are there, right? It's a lot more maintainable, a lot more readable code, and also it's a lot easier to work on this type of pattern.
Right, it looks like a lot of setup ahead of time, but that pays itself off in dividends in the long run.
Definitely. I mean, if it's a small project, I mean, no one cares about design patterns, but we're talking about enterprise applications. And enterprise applications are large enough for 100 people to scratch their heads simultaneously.
And this pattern, it's one of the best practical examples of the solid principles I've ever seen. The whole time you were demonstrating this, I kept thinking about the last big project I did and how much of a pain it is to extend it at all. I kept thinking, if I could go back and redesign it, this is the strategy I would use.
Yeah, definitely you can. I mean, this is what dependency inversion does. Instead of saying dependency inversion, instead of saying that what strategy this will be using, we inject the strategy into the animal from person. This is injecting the behavior here in animal instead of initializing it here itself. So this is the kind of dependency inversion thing we're doing. It's just more advanced level of dependency inversion. We are following the single responsibility principle. We are following Liskov's substitution principle, I guess, because we are implementing the interfaces, right? So design patterns basically are a broader use case of solid principles. The base is solid principles itself.
Well, it's certainly interesting to see, and I can see a lot of practical use cases for it.
Yeah. So talking about practical use cases, I mean, strategy pattern can be applied anywhere where we need to choose and change a behavior. Like, for example, we can say uh, maybe a compression application which compresses files. There can be different strategies for compressing files. There can be RAR strategy, there can be a zip strategy, right? So if
right, and the only thing the any class that calls that compression class is going to need to know is that there is a compress method that it can rely on. It can call.
Exactly. It just calls the compress method. Simple as that. I mean, you're a fan of cryptographic algorithms and implementations, I know. So we can do one of the strategy patterns into there as well. We can have different implementations, like say DES algorithm, AES algorithm, and we can choose on runtime which algorithm we want to use. All we need to know is it has an encrypt method. Also, like maybe it can be used in sorting applications where we have to sort files or numbers. How they sort, if say numbers, does it use quick sort or merge sort? We can provide those implementations and interchange those implementations. So that's basically how strategy pattern can be used. And we were just talking about how this can be used in test cases as well.
Oh yeah, it could be used if you are taking a test-driven development approach to your application development. It can be used to, for example, inject a test data provider instead of having to rely on a database for all the time. And when you're testing and you have to rely on database to get your data, it means you always have to go back and set up your database to make sure it's exactly the way you want it. Instead, you can just go ahead and have a class that implements whatever your data abstraction method or your data abstraction interface is, and fill it with your test data and pass it into the method you want to test.
Yeah, definitely we can do that. I mean, it will be a lot easier for test-driven development. All you need to do is change just a single line and it changes from actual database to the test database. Right. That's, I guess, basically it for this webinar. That's all I wanted to cover in this webinar. We'll be talking about, if we do continue doing webinars, we can talk about different design patterns later.
Excellent. Well, I'm certainly appreciate the knowledge you laid on us today, man. It's this is what I'm probably going to pick up and start using tonight.
Well, definitely that's what I wanted. I mean, people learning this is what I wanted. I mean, I just I don't have I haven't used this design pattern as such in production anyway yet. But I was just reading and the book went through how this can be used, and I was just intrigued. Like, this is one of the best things I've read. Design patterns. They're just so thoughtful. I mean, the people who made these design patterns, there must be some intelligent creatures. I mean, they're not humans; they're creatures.
Absolutely. All right. Well, I think that about wraps things up on our end. Let's.
Yeah.
Well, thank you everybody for watching. I think we've got 3 people watching right now, so large crowd.
Yeah. So, do we have any questions on the chat? Can you see that?
No questions that I can see. Before we sign off, does anybody have any questions for us?
Yeah, we can wait.
And the audience is silent. I will take that as a collective no questions.
Well, most of them are my friends, so they'll be just sending me WhatsApp messages if they have questions.
All right, well, that about wraps things up for today, I think. What do you think, Steve?
Basically it. I mean, you people can tell me if you want a follow-up webinar where we can discuss more of the design patterns. Would you like that?
Yeah, I'd be in for that.
You can give one webinar, I guess.
That seems like a lot of pressure. I don't know if I could do that.
Well, I'll try to learn more. We can do a podcast thing, something.
That would be interesting. There's only a handful of good software development podcasts that I've been able to find, so I feel like that's an unsatisfied market there.
Yeah. I guess I think we can do that. I mean, we keep talking a lot about different things. We can just do that live somewhere and record that. That works.
Yeah, similar to what we're doing now. The hard part will be explaining it in an audio-only medium. Like,
yes,
that'll be
that's the most difficult thing. I mean, if you see at the diagram I just showed, this, you can see that.
Yeah.
We did approximately like 40 minutes or 60 minutes of work. And this simple diagram explains it all. Now imagine if we have to explain this only by audio.
I feel like that in itself is going to be an extra hour just trying to convey it without the use of a diagram like this.
Yep. So visual things makes it easier, a lot easier. Yeah, we can do it on Hangouts. We can create diagrams beforehand and maybe just go through the diagrams.
Add it like show notes or what have you.
But yeah, we can show notes. We can scan our notes, what we write. We can create notes on maybe, I don't know, MS Word or so.
Yeah.
Do you use MS Word, by the way? to make notes? Who uses MS Words?
I use Notepad.
Yeah, Notepad or Gedit.
Yep.
That's what we use, right? Oh,
All right.
did Mike join? Did Mike
Let's
join in?
I don't know. I don't think so.
Neither do I.
That's all right.
Well,
This was recorded, right?
yeah, this is recorded and it'll be at the same link.
Yeah. So he'll be able to check it out, and we'll be able to get feedback from him when he's got some spare time.
Yep, definitely. Let's see. I guess this wraps it up.
All
How
right.
many
Let's
hours
go
did
ahead.
you guys?
Hmm?
1.5 hour. Went for 1.5 hour.
That's not so bad.
I was expecting 1 hour, but I mean, explaining such a thing can take time.
Yeah.
Yeah. So let's just go off here, right? And thanks for watching. And there's Jeff, that's the man.
Thanks, guys.
Bye. Bye, everyone.